Okay, so in this video we're going to review a couple of examples of travel forecasting at the project level. I'll go through the process that's explained in the ITE Trip Generation manual. Okay, so the first step, of course, we've got an example here. Let's say we're going to build a new Walmart. Okay, and we need to know what the key variables are. Well, the ITE Trip Generation manual lays that out for us pretty nicely. Okay, the trip generation equations that they've collected over the years are based on hundreds of studies nationwide, based on historical data. So they relate typically for, let's say, for example, a shopping center. They'll relate number of trips per hour, new trips per hour, as a function of gross leasable area. So T is the number of trips. X would be the number of thousands of square feet of leasable area, and this equation pertains to a particular situation, so PM peak hour. Now, when you build a shopping center, there are new trips that are generated. People come to the shopping center specifically for that purpose, but there are also people who are already on the road who, oh, gee, there's a shopping center there now. I think I'll stop in on my way to wherever I was going anyway. Okay, so those are called pass-by trips. And again, we have historical data that will give us an estimate based on the shopping center size of the percentage of pass-bys. Okay, so let's say we have this Walmart and it's 110,000 square feet, and we want to know how many new trips will be made and how will this impact our existing roads. To evaluate that, we need to know what all the turning movements are, how many trips are made in each lane, and so forth. Okay, so let's take a look at this. Let's say we're going to build a Walmart along 114 east of here, along by Middleton, toward Middleton. And let's say this is the area, parking lot plus building, and we're going to put a new driveway in right here. Okay. If we do a schematic, it's a little clearer. So we have 114 with existing traffic, and we're going to build a driveway into the Walmart. Okay, so we need a method for estimating the new trips that will be made to get a turning movement diagram here. Okay. So this is an example of a table out of the trip generation manual. Okay. And you can see that this is for shopping centers, and for PM peak hour, under 110,000 square feet, we have an equation that will give us the number of trips made during that peak hour for a given size of shopping center. Okay. And once again, we have the percent pass-bys given as well. Okay. And this is all based on historical data. So we're going to use this equation. We also know how many are coming in, how many are going out during that PM peak hour. Okay, so in schematic form, we can do this. So the first thing to do is find the total trips. So the total trips is that equation solved. So plugging in 110,000 square feet, I'll come out with 655 new trips. Now, what percentage of those are pass-bys? Well, we know that there's 110,000 square feet, so there will be about 42% pass-bys of these. So the percent pass-bys are 42% of 655. So 279 trips will not be new. They'll be existing trips already on the road, but that will come into the shopping center. And then 49% of those will go in, and the rest will go out. Similarly, for new trips, there's 655 total minus the pass-bys. 655 total minus the pass-bys gives how many new trips will be made specifically for the purpose of going to Walmart. And 49% of those, again, will go in, 192 will go out. Okay? So let's do pass-bys first. We're going to distribute these pass-by trips. These are the pass-by volumes here, in and out, as we showed before. Now we know that 40% of existing traffic comes from the east. as I've got it shown here. So 400 trips come from the east, 40% of the in traffic. So we know that there's 137 trips coming in, so 40% of those, or 55, will turn left from the east to come into the driveway. But those are existing trips, so they don't add to the 400. They get the 55 of the 400 we're passing by anyway. They're coming into the shopping center. Okay. Now there are 82 left over. They're coming from the other direction. Again, those aren't new trips. They're already on the road. So 518 will go through, and 82 will turn in. So those are the pass-bys. Now exiting, we know that 40% are coming from the east, right? So if they turn in here, when they leave, they're going to go in the same direction. They're going to continue on. So 40% exiting will turn left. 57 trips will turn left. And 85 will turn right. The remainder will turn right. So these are pass-bys. So now let's take a look at new trips. Okay. So we have these are the trips in and out for new trips. Again, 40% are coming from the east. Therefore, 40% of the 184 will come from the east. That's 74 trips. But those are new trips. Those aren't part of the 400. So now we're going to add the 74 to those left turners because those are new trips. Okay? So we have 129 turning left. And the remainder from the west, 110. Again, new trips, not part of the not part of the 600. So that's 192 turning in. And now the 192 exiting, we know that 40% came from the east, and these are new trips, so they'll presumably go back home, right? So 40% will turn to the right, and 60% will turn to the left. Okay. So now let's pull this all together. We have 115 and 57 turning left, and 77 and 85 turning right. And if we put that in a turning movement diagram, there we are. So now we can analyze this and assess the impacts of this development.